Hello and welcome to MC Math 02 College and Advanced Algebra, and this is your third lesson on the topic of real number systems. And today we're going to learn about two things: the absolute value and distance, and the exponential expression. Now in this lesson, we're going to learn about two things. At the end of this lesson, we will be able to define and compute the distance between 2 points and evaluate exponential expressions. Why define? Because we're going to learn about a notation that will define the distance between 2 points. How do you indicate in a form of writing that you're referring to the distance between 2 points? And we're going to solve for the value. We're going to compute for the value of the distance between these 2 points using a formula. Second is we're going to evaluate exponential expressions. We're going to learn about what an exponent is, how do you write an exponential notation, and how do you evaluate exponential expressions from an expression to, let's say, a value, a singular value. Let's begin with the definition of the distance between 2 points on a real number line. If you remember, a real number line is a number line that extends to the left and to the right, where on the right you will find positive real numbers and on the left you will find negative real numbers. The extension is indefinite. It extends to the right indefinitely and to the left indefinitely, approaching infinity on both sides. On the right, it approaches positive infinity. On the left, it approaches negative infinity. Now, let's say on the real number line, you have 2 points. Let's say we have point A somewhere and point B somewhere else, not on the same location on the real number line. And let's say that point A is represented by a coordinate and B also by a coordinate. But since you're in a real number line, then it's intuitive to think that you're either in x-axis or in y-axis. So you don't need a pair of numbers. You only need one number to describe the location of a point or to describe the point. Coordinate of that point is only a number. So let's say if A and B are the coordinates of 2 points on a real number line, then the distance between the graph of A would simply be an oversized, or because a point doesn't have a dimension, but in the graph you'd make it bigger than usual so that it's easily seen. Point on the line itself of A and the graph of B. You can denote the distance between the two of them by writing the letter D and enclosing A and B on inside a parenthesis, a set of parentheses. D, open parenthesis A, comma, space B, close parenthesis. And you can compute for the distance between these 2 points by subtracting B from A, that is A minus B, and getting the absolute value. It's the absolute value of A minus B. That's the formula. Notice that we have here A and B. To emphasize, this A and this B are points. And imagine a real number line like that one in the example, where the center, it's exactly in the center, is the origin, the 0. The graph of A is a point. You can see it there. It's not a hollow point, it's just made hollow for emphasis, but it's a point. And there's a name A in there. So that's the point. And D, and then the points inside the parenthesis. This is the notation for the distance between the A and the B. Also, let's have an example here. Let's say the distance between 4 and 5 on the real number line is denoted by, let's say the distance between 4 and 5. So on the real number line, it's denoted by the distance, D, between negative 4 and positive 5. How do you compute for that? So using the formula, you get the absolute value of the difference between negative 4 and positive 5. And that is the absolute value of negative 4 minus 5. And we know what negative 4 minus 5 is, and that is, yes, you got it correctly, that is the absolute value of negative 9. So you get the distance between negative 4 and 5 is 9. Notice that there is no unit because the distance is relative. So it's relative to the distances between the numbers, the real numbers, the placement of these real numbers in the number line. So it's relative. You don't say 9 centimeters or you don't say any other dimension, but basically it's 9 units. We don't know what that unit is. Let's have another example. We have here, express the distance between 5 and negative 2 on the number line using absolute value notation. So we just need to express this into absolute value notation. So simply put, all I need to do is to write d, then 5 and negative 2 inside parentheses separated by comma and space. That's the distance between 5 and negative 2 is equal to the absolute value of 5 minus negative 2. So let's try to evaluate this. Let's try to solve this. The problem calls for this expression only, but let's try to proceed into computing for the distance between 5 and negative 2. It's the absolute value of 5 minus negative 2. If we simplify that further, we get the absolute value of 5 plus 2, because minus negative becomes plus, right? If you have a problem with operating with signed integers, you can check your class. I'm going to upload a reference material there, an additional reference material for you to check so that you will have a chance to improve your skills in operating with signed numbers. So what's absolute value of 5 plus 2? And that's absolute value of 7, which is 7. So the distance between 5 and negative 2 is 7 units. Express the distance between negative 17 and negative 5 on the number line using absolute value notation. The notation is simply d, negative 17, negative 5 is equal to the absolute value of first number first. So it's negative 17 minus negative 5. How about if you would like to set negative 5 to be a instead, and negative 17 to be b instead? That is the purpose of the absolute value notation. It ensures that even if you interchange the numbers, you'll get the same value for the distance. So that's why we're using it. So usually if we're not going to use the absolute value notation, what happens is if you switch numbers, you'll get the same number but different sign. Let's say the original distance, if you subtract b from a minus b is equal to, let's say, positive 10. If you switch a with b, usually it becomes negative 10. Always it becomes negative 10, or usually. So the absolute value notation ensures that the answer remains the same. It's in the positive form. So we have the distance between negative 17 and negative 5, or negative 5 and negative 17 is equal to the absolute value of negative 17 minus negative 5. Or you can do the other way around. That's negative 5 minus negative 17. So we can rewrite this into absolute value of negative 17 plus 5. Then the minus negative 5 becomes plus 5. And solving further, we have negative 17 plus 5 is equal to negative 12. So the distance between negative 17 and negative 5 equals 12. Now since this is a recording, you have time. You can pause this video, get a piece of paper, try the other way around. Try negative 5 minus negative 17 and see whether you will get the same value, that is 12, for the distance between these 2 points. Let's explore another example. Express the distance between x and negative 13. Now this time, because we have a variable, it would be difficult to get a value for the distance. So we would end on the absolute value notation unless we have the value of x. How do you write the notation for this? What you do is, that's d, and then your a would be x, so it's okay. You can have x for the b and 13 for the a. It doesn't matter since it's absolute value, but let's say x is your a and negative 13 is your b. So you place x first and negative 13 afterward. I'd like you to practice using this notation where after the first number there's comma and space, and then we have the second number and then parenthesis. There is no space after the parenthesis or space between d and the open parenthesis. I'm telling you this so that when we have a quiz after the live discussion, which is scheduled today, September 11th, around 2 to 3 p.m., you're going to have a quiz. When you write down your answers, it will be checked automatically by the platform that we're using, which is Google Forms. So I don't have to manually check them. Absolute value of x, the first number that you identified, minus negative 13. If we're going to rewrite this, it becomes absolute value of x plus 13. And we can go on and further because we don't have the value of x, so that is the notation that we're looking for. So to wrap up, to summarize, the distance d between x and negative 13 is equal to the absolute value of x plus 13. Let's have another example. Express the distance between negative 2x and negative 4x on the number line using absolute value notation. So using the formula that we have, let's identify what's a and what's b, but remember that it doesn't matter what number you choose for a or b. You can interchange them because it's absolute value. So for the purpose of this, let's have negative 2x as your a and negative 4x as your b. So using the formula that we have, it's negative 2x, the distance between negative 2x and negative 4x. So it's equal to the absolute value of negative 2x minus negative 4x. We have negative 2x plus 4x. And we can simplify this further. We have negative 2 plus 4 is equal to positive 2. So that's 2x. We have absolute value of that is 2x. So let's try to read the comics that we have here. It's from Peanuts. Schroeder, I think this is the pronunciation Schroeder. Schroeder, according to the girl. The girl is talking to Schroeder. Schroeder, what do you think the odds are that you and I will get married someday? And then he responded, oh, I'd say about Google to 1. Curiously, he said, how much is a Google? And then Schroeder began with 1 and then followed by these zeros. If you have time, you can pause this video and you count the number of zeros there so that you know what a Google is. And then the girl sighed because it's obviously it's a very big number. I imagine it would even take a lot of time to finish saying the zeros. So what is a Google then? And why is it important? Why are we talking about a Google? Google originated with not really this man, but I'm going to show you this man because it's important. He's a mathematician. His name is Edward Kastner. You can read the quotation later and you can explore the meaning of this, but we're not going to explore the meaning of this. I'll leave it to your history of mathematics. If you encounter Edward Kastner, you can talk about the meaning of his quotation, of this quotation. So Edward Kastner has a nephew. During his time, he's 9 years old, and playfully he said a number followed by, if you counted that, you'd know 100 zeros. So that's a Google, according to the nephew. And Edward Kastner honored that idea from the kid and named such a number, Google, 1 followed by 100 zeros. That number is very huge, though. It cannot be operated on our normal calculators. But we have powerful supercomputers now, so it's not impossible to operate on that. How big is that number, though? That number is so big that even if you count the number of matter, the number of atoms in the entire universe, it would still be less than a Google. Last time I checked, the number of the estimate of the number of atoms in the universe is 1 followed by 80 zeros. A Google is 1 followed by 100 zeros. If you disagree, or if you find a new literature that says otherwise, like that speaks about the number of matter in the universe, if it's no longer 1 followed by 80 zeros, then you can comment down. I am going to upload this in YouTube before I post this on the Google class, so you can comment down either on YouTube or you can comment on the Google class on the post where it is posted, where this material is posted. You can comment either privately or publicly so that your classmates can see and your classmates can respond, and we can have an interaction in a fun way. So that's there. Now, a Google is a Google is 1 followed by 100 zeros, or more conveniently, since if you notice that writing 1 and followed by 100 zeros is very, you know, it demands a space. Imagine if you're calculating and you would need to repeat the same line many times, and you're going to write a Google. That will be a lot of pain, that will be a lot of trouble. So to simplify the notation, we can write it as 10 raised to 100. So what is this expression? Highlighted in yellow. What is 10 raised to 100? What's that? And how is that even used? If you've never met a notation like this before in your life, then you'd be confounded. You'd be baffled. You'd be baffled because there is a number slightly raised on the right side of another number. So what is this? This is, before we proceed, the Google, that's 1 followed by 100 zeros, supposed to be currently a very large number that exceeds the number of matter in the universe, the number of atoms in the universe, so to speak. I don't know if it's atom or matter. You can, write it down below, but I'm positive it's atom. Is the basis, supposedly, is the basis for the name of the company Google. Okay, so I'm gonna create an activity later on. You can check it, asking for your opinion why the name of the company is Google based on the number Google. You can write your answer as a reflection, but it will be posted later, so wait for it. Okay, so what is that notation? Going back on the question that we had earlier, what is that 10 raised to 100 notation? What is that? That is exponential expression. So consider the following example. We have 3 times 3. The dot operator that you see is multiplication. It signifies multiplication. So we have 3 times 3 times 3 times 3 times 3 times 3. The 3 is multiplied to itself 6 times. So you can simplify that by writing 3 and then writing a superscript. You call that a superscript because it's elevated. If it's below, it's a subscript. So 3 and then 6, meaning the 3 is multiplied to itself 6 times. So that's 3 times 3 times 3 times 3 times 3 times 3, 6 times. So this notation, the 3 raised to 6, is an exponential notation. It's called an exponential notation. Let's have another. We have 1 half times 1 half times 1 half, 1 half, 1 half, 1 half. It appears 7 times, so it's 1 half raised to 7. We have x multiplied to itself. So if you count, it's 17, so it's x raised to 17. We have 3y multiplied to itself 5 times, so it's 3y to the 5th. It's not 3 to the 5th or y to the 5th. It should be 3y enclosed in a parenthesis to the 5th. So the definition of natural number exponents is if b is any real number. You know what a real number is? A real number is either rational or irrational number. And n is a natural number, meaning counting number excluding 0. So if we write b and n is its exponent, it's raised, there's a superscript n such that n is only a natural number, then we could say that such notation signifies that b is multiplied to itself the number of times n is. Let's say b to the 7th. So b is multiplied to itself 7 times, and so on and so forth. B is called the base. So that's your base. And it's important that you identify the base correctly, because if you don't, then your answer may become wrong. Later on, we're going to explore what that means. And n is called the exponent. So we have the base and the exponent. Okay? Let's have an example here. We have 2/3 raised to the 3rd power. That's how you say it. So it's multiplied 3 times. 2/3 times 2/3 times 2/3. And when we multiply fraction or fractions, we simply multiply their numerators and we write it as a numerator of the product, and their denominators, and we write it as a denominator of the product. So 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. So that's 8 over 27. Okay. So in here, we have -3 raised to 4. Notice that the base here is 3, not -3. So you're going to multiply 3 to itself 4 times and then apply the negative sign. So it's negative, open parenthesis, and then you multiply 3 4 times. So the answer is -81. Again, when there is no parenthesis, the base is just the number, not including the sign. So here's an example where the sign is included. So in here, we have close and open parenthesis. Inside parentheses, -3 raised to 4. So that is, the base is -3. -3 times -3 times -3 times -3. So that's negative, positive, negative, positive. The result is positive. So we have 81. It's positive. Okay. So let's try to evaluate here an example. We have -5 squared multiplied by -2, the quantity -2 squared. And another, we have -2 squared divided by the quantity -2 squared. So I'm going to give you time. You can pause this. In the live discussion, I'm going to ask people to solve this. So if you watch this video beforehand, then you can study, but I'm sure that you won't have enough time because I'm going to upload this very soon before the start of the live discussion. But if you're watching this because you missed the live discussion, or you just want to review, then I'd like you to pause this video and then try to solve so that you get a chance to practice and to test whether your ability to identify the correct base is already on point or not, or if it needs some improvement still. Okay, so if you're ready, if you've already solved, and if you unpaused this video already, then you can proceed. Okay, so let's proceed with answering. The first one first, we have -5 squared multiplied by the quantity -2 squared. So notice that in the first one, the negative sign is not included, so it's outside. It's 5 times 5, which results in -25. And the second one is -2 times -2, which results in +4. The answer is -100. Our last example. Proceed with caution. If you have an answer, then proceed so that you can understand. If you want to study the solution for the first example, you can pause it before you can continue. So we have here -2 squared divided by the quantity -2 squared. So simplifying, again, in the first one, the base is 2, not -2. So it's negative, and then the quantity 2 times 2. And the second one, since it's the quantity -2, so the base is -2. So -2 times -2. So evaluating, we get -4 divided by +4, which results in -1. So that ends the example for the definition of natural. So let's try to wrap up. This session we'll learn two things. First is, we learn the definition of the distance between 2 points on a real number line. First, we learned that the distance is denoted by D, and then close and open parenthesis, we have A and B. And the value of that is the absolute value of A minus B. Also, we learned that even if we interchange the letters, even if we interchange A and B, since it's absolute value, the result would still be the same. Also, we learn about the definition of natural number exponents. If b is any real number and n is a natural number, then b raised to n is equal to b multiplied to itself as many times as the value of n, where b is we call b as the base, and n we call the n an exponent. Also, we learned further that when we have signed integers, as we have signed integers and we have an exponent, the base doesn't always include the sign. It depends. If we have a signed number only and the number is raised to a particular exponent, then the base is such a number. But if we have a signed number inside a parenthesis and the exponent is outside the parentheses, then the base includes the sign. So that's what we learned. So yeah, that's pretty much it. This is the end of our lesson 1.c. This is the third lesson under the topic on real number systems. If you find my discussion to be fast, then you can slow down by reducing the speed in YouTube. You can find that in the setting. The setting can be accessed using the gear icon that you can find in the lower right portion of your screen, or it depends on your model of phone. I don't know, maybe the settings would be located somewhere else. You can find it by clicking the gear icon. Also, you can enable the closed caption. I will enable it when I upload this video on YouTube, so that you can read whatever I'm saying to assist you better in your understanding. If you find that you forgot some concepts, or you want to review a concept on these two lessons, two things that we learned today, so you can just replay as many times as you like. This will be available in the class and on YouTube for you to learn better. You can also find questions in the material that I uploaded. You can solve at the end. There's a section there that includes a lot of questions. You can solve as many questions as you want. You can contact me and I can respond to you as soon as I can, whenever I'm I'm no longer occupied with the things that I'm doing, either personally or professionally. So you can send me your solution. Make sure that when you ask a question, you've already solved it, and you send me a solution so that I could check which part which part needs some improvement. If you cannot proceed with the solution, then we can work things out together. So thank you for listening. I hope you have a great day ahead of you.